Hello everyone, in this session we will cover the future value and the present value of a single amount. Now before we proceed, I want to make sure that you have viewed the prior recording which explained the simple interest and the compound interest. So it's essential that you understand how simple and compound interest work in order to understand the time value of money. I cannot emphasize the importance of the present value and the future value of a single payment for your finance and accounting education as well as your career. Now, these concepts are used in the real world, but in this recording, we will focus on helping you understand the present value and the future value of a single payment for your accounting and finance courses. Whether you are a CPA exam candidate, a CMA exam candidate, an accounting, a finance, a business student, this is a critical concept that you need to be familiar with in order to value a bond, an investment, a stock. Anything that you want to value, you need to understand the time value of money. It's not an understatement if I state that the present value concept is the foundation of finance, is the foundation of your finance career, because finance is based on discounting cash flow, which is using the time value of money techniques. So let's go ahead and dive into the future value of a single payment, the present value of a single payment. I emphasize here single payment. Why? Important. In the next session, we would look at the present value and the future value of an annuity or multiple payments. There's a difference between a single payment, a single amount, and an annuity, multiple amounts. At the end of this recording, we would also look at a multiple choice question. Let's go ahead and get started. Before we proceed any further, I have a public announcement about my company, farhatlectures.com. Hello, my name is Farhat. You are here because you are either an accounting student, a finance student, or someone who's studying for their CMA or CPA exam. Great. You are looking for some additional help, and we can help you. I strongly encourage you to visit my website, farhatlectures.com. I offer additional lectures, resources, including PowerPoint slides, multiple choice questions, in some circumstances, exercises, and true-false questions. Our material is aligned with your CPA review courses, with your CMA review courses, with your college courses. I offer a risk-free trial that you can try to find out whether my website can help you or not. If you find it helpful, you subscribe, you keep your subscription. If not, you cancel and your risk is free. If you like this recording, if you like my lectures, you would like what's on the website, give me a chance to help you with your college courses as well as professional certification. I hope to see you on the website.
Let's first discuss what practical uses individuals or businesses could utilize the future value for. In other words, why do we learn about the future value? There's practical application to it. Whether you are an individual saving for your retirement plan, you will need to know how much is the future value of the amount that you invest. For example, if you have $10,000 today and you are planning to retire in 15 years, you could earn 8%. How much you would receive in future value? How much would that $1,000 be worth in 15 years? And you would learn how to do this in maybe a few minutes. For example, parents wants to save for their child's education. They have $5,000 to invest today. They can earn 6%. How much money they will have in 15 years if they invest this money and earn 6%. A business want to buy a machinery for $100,000 5 years from now. Today they have $75,000 and they can invest this money at a 5% interest rate. How much money they will have in the future. So what I want you to see is this. Future value is, you know what you have today, you know this amount is known, you want to know how much is this amount worth into the future. Now you're going to see, we're going to call the amount that you have today called the present value. The present value is how much you have money today. So the future value represents how much an investment made today, the investment made today is called the future value, will grow into the future value, and this will grow over time, and interest will play a role in accumulating more money. So The future value is dependent upon how long you're going to invest this money and how much is the interest rate. Now, what you need to know is this: the longer you keep investing your money, the higher is the future value, and the higher is the interest rate, the higher is the future value. The best way is to look at an example. Let's assume you have $50,000 today. You can invest this money at 6% compounded annually. And I emphasize the word compounded and I emphasize annually because in the prior session we looked at compounded other than annually, and we explained the concept. We will work an example today, but I want to make sure you understand, as I told you at the beginning, you want to understand the difference between compounded annually versus simple interest versus compounded semi-annually. So this is compounded annually at 6%. The number of periods is 5 years. So you will keep this money for 5 years. So let's assume we want to solve this problem. Well, there's a formula. There's a mathematical formula. The future value of an amount equal to its present value times 1. 1 represents the present value. It means the amount will have to be compounded. Plus I. I is the interest rate raised to the nth power. The nth power is the number of periods, happens to be 5 years. So if we use this formula and we solve for the future value equal to 66,912, which will be 50,000 times 1 plus 06 raised to the 5th power will give you 1.33823. We call this the future value factor, and you will see it later on shortly. So if we take the amount, the present value, times the future value factor, will give us a future value of 66,912. Simply put, the $50,000 today, if you put it in the bank and you forget it for 5 years, you will come back and pick up 66,912. Let's prove it. You put this $50,000, it will grow at 1.06. A year later, it will be 53,000. You will keep this money in the bank account. In year 2, it will grow at 1.06. It will grow to be 56,180. You will keep this money in the bank account for year 3 at 1.06. It will become 59,551. You will keep this money again year 4, growing at 1.06. It will become 63,124. Year 5, the last year, you will keep this money. It will grow at 1.06. You will go back to the bank account and collect 66,912. Now, as you can see, this computation, if you're doing this manually, it might take time. If you're using the calculator, you may not know how to use a calculator, or you may not have a calculator. What happened is this: in your college courses, in your finance courses, accounting courses, you will be provided time value tables. And those time value tables already computed the factors for you, the factors. So the time value table would look something like this. Usually it's in the appendix of your textbook or in the appendix of the chapter, or it could be embedded inside the chapter that you are working with. And this is the future value of $1, future value of a 1, and the interest rate will be on the top, 1, 2, 3. This is how much you are going to earn, and the period on the side, 1 period, 2 periods, so on and so forth. For this illustration, we have 20 periods and up to 15%. So what you will do, if you want to find the future value of a dollar amount, and the dollar amount is 50,000, what's the future value of this amount? We said that we need to invest this money at what rate? 6%. So we go to 6%, and we go down, and we're going to keep this money for 5 years. 5 years is here, and they meet at 1.338. So if we take 50,000 times the factor 1.338 equal to 69,912. Now when I use the calculator, it went to 1.33823. It's just rounding. But 1.388, I don't want to round, I don't want to have more decimals, it would look really messy. So that's why 1.338, and it will give us this amount. Now also in your finance course, you would use a financial calculator to perform this computation. So that's another way to do it, or you could use the time value table. Now, remember we talked about compounding. Let's change this example. We're going to use everything the same, except that this 50,000 will be compounded semi-annually. So you're going to put this 50,000, and it's going to compound interest every 6 months. So you're going to multiply it, but the interest rate will be different because the interest rate here is not 6%. The interest rate becomes 3, and you're going to compound this over 10 periods. Remember, if we are looking at 5 years compounded semi-annually, this is 1, 2, 3. Let me just do 5 years, then compounded. So this is if we're looking at 5 years. 1, 2, 3, 4, 5. This is 5 years. Year 1, year 2, year 3, year 4, year 5. And clearly those are 5 periods. And we set the interest rate annually 6%. If we compound semi-annually, it means we have to break each year into 2 parts. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 periods. So when we go to the table to look for the periods on the side, we look at n equal to 10. N equal to 10, then the interest rate is no longer 6. The interest rate, since it's semi-annually, so every 6 months we're earning 3%. The interest rate is 3. Therefore, what we do is we go to n equal to 10, I equal to 3, and we look at the factor, the present value factor, 1.334. Therefore, we'll take 50,000 times 1.344, and the amount will be 67,222 versus 66,912 if this amount was compounded once a year. And you'll see the difference is $288. What's $288 over 5-year period? True, but if you're investing millions of dollars, then it makes a difference. So compounding is a very powerful tool in accumulating wealth. Now here I compounded semi-annually. Think if we compounded quarterly or if we compounded monthly, the amount will be different, way much different, and we learn how to compute the effective rate in the prior session, so we are not going to do that. So now we're going to move from the future value to the present value, and I believe as an accounting student you would use the present value much more than the future value, and usually the present value is more challenging for students to understand, and the reason because we all want to know how much we will have into the future. It's an easy concept to understand. If I invest, if I put my money in the bank account, but what is the present value? So how is it used in the real world? Well, the present value is actually more useful, that has more usage in the real world. Why? Because when you want to decide on an investment opportunity, okay, let's assume a company is considering an investment opportunity that promises a payout of $100,000. So we're looking into the future and someone's saying, I'm going to pay you $100,000 5 years from now, not into the future, 5 years from now. We're today here and someone's telling you 5 years from now, I'll pay you $100,000. The company wants to earn 8%. The company says, if I'm going to make any investment, I want to earn 8% on this investment. How much will I need to invest today? What's the present value today so I can have a future value of 100,000? Now, I did not mention something earlier, and I will need to mention. Let me go back and mention it. When we're dealing with time value of a single amount, you're going to have 4 factors. You're going to have the present value. You're going to have the future value. The present value is today. The present value is what you have today. The future value is the future. You will have to have the I, which is the interest, and you will have to have the N, which is the period of time the money will be compounded for, the number of periods that you're going to be waiting. So those are the 4 factors: present value, future value, interest, and period. And as long as you know 3, you can figure out the 4th. So the present value here is not known. So we don't know how much we'll need to invest. This is what we need to find out. A car loan evaluation. A car dealer offers a financing deal where it can either pay $25,000 in cash or finance the car and pay $27,000 2 years at 5%. What's the present value of this deal? This is what we need to find out. Those are application. Retirement savings. An individual wants to have $1 million saved by retirement in 15 years. So somebody says, I want to have $1 million 15 years from now. They can invest one amount today. So the future is 15 years from now, and they want $1 million. $1 million. So this is the future value, and the time is n equal to 15 years, and they can earn I equal to 7%, and they can earn 7%. How much they will need to put away today? What's the present value today? That in 15 years they will have $1 million. Again, we're going to be able to solve all these questions. Give me a few minutes to show you how to solve them. Or for a personal level, a home purchase. A family is considering buying a home for $300,000 10 years from now. So we have a couple, a family said, we want to invest money today to have $300,000 as a future value 10 years from now. We can earn 6%. How much money do we need to put away today? So this is the present value. So first, let's take a look at the computational of it. So it tells us how much we need to invest today to achieve a specific future value, whether to buy a home, a boat, education, retirement. Okay, so let's assume the present value of $30,000 needed in 5 years. So we need $30,000 in 5 years. This is what it looks like. So this is the future value, 30,000, and this is 5 years from now. How much do we need to invest today, assuming we can earn 7% compounded annually? So what's the formula? Here's the formula. The formula equal to present value equal to future value divided 1 plus I raised to the n. Obviously, you're going to say, I saw this formula. Yes, you saw it. Future value equal to present value times 1 plus I raised to the n. All what we did is we solve for PV. If you solve for PV equal to future value FV divided by 1 plus I over the n. So it's the same formula rearranged. Now if we do that, if we apply the formula, we'll take 30,000 divided by 1 plus 07 raised to the 5th power. You're going to get 30,000 divided by 1.40225. You guessed it, this is the present value factor. And we'll get 21,390. What does that mean? It means today, if you put away today 21,390 today, and you forget about it, for 5 years you will have $30,000 for that car or that boat or that down payment for a house that you want to buy. Let me prove it to you. If we put 21,390 in the bank, earning 7%, it's going to become 22,887. If we keep this money in the bank account, let it grow at 1.07, year 2 it will grow to 24,489. If we keep this money in the bank account, let it grow at 1.07, will come up to 26,203. If we keep this money in the bank account, year 4, earning 7%, it will become 28,037. If we keep this money in the bank account and let it grow in year 5, the last year, at 1.07, we are going to get 30,000. Now again, this computational could get messy. In your book, in your textbook, in your CPA review course, in your CMA review course, you will have a present value table, present value of $1, already computing all these factors for you. So to solve this problem, if we go back here, it's 5 years at 7%. Make sure you're looking at the proper table. 7% is right here. Let me use a red pen here. 7% is right here. 5 periods is here. And they meet at 0.713. If we take 30,000 times the present value factor of $1, and when I say $1, it means one payment. We're making one payment. And why do I keep emphasizing this? Because eventually we're going to be using another payment. You will need 21,390, which is the same amount that we find out using the formula. Or obviously you could use a finance calculator. I don't teach you finance calculator because there are different calculators, but in your book and the manual you could easily compute this. Now the same concept applies for compounding. If the interest rate is different, then you'll have to, if the compounding is not annually, you'll have to adjust. It's the same thing. So let's take a look at an example. You plan to purchase a car in 5 years for $30,000. You want to know how much to invest today if the interest rate is 6% annually and 6% compounded annually. So you're going to put some money today to have $30,000 to buy that car. So if it's annually compounded, you will take the future value divided 1.06 raised to the 5th power, which is 30,000 divided by 1.338 equal to 22,429. Or you can take 30,000 times, you go to the table, I equal to 6 and equal to 5. Okay, I equal to 6 and equal to 5. I equal to 6. I equal to 6 and equal to 5 is 0.747. And if you take 30,000, let's do it, times 747. Let's do it. So let me compute this just to make sure. Let's take 30,000 times 0.747, and that's going to give us 22,410. Now the difference is rounding, but you got the point. Okay, 22,410. Maybe it should be, 0.78, whatever, if it's rounded more. But this is the amount, 22,000. So if you let this money compounded annually, you will need 22,424. Now I'm going to go ahead and compound this problem semi-annually. And my question to you is this: will you need to put away more than 22,429 or less if the amount you put today is compounded semi-annually? And I hope you know you'll need to put less money away because you are going to earn more as the 6% becomes 3%. You're saying, how do I earn more if it's 3%? It's 3%, but the number of period becomes 10. So now what we need to do, we need to go to the table, look at, let's keep this was the old one. Now what we do is let me use a different color here. Now we're going to be using 3%, and we're going to go to 10 period, and the factor is 0.744. So now what we do is we take, let's do it manually. So we're going to need 30,000 times 0.744. Let me do this. 30,000. Again, might be slight differences because of rounding. And that's 22,320. So notice, if it's compounded semi-annually, you will need only 22,320. So if we compare 22,334 versus 22,429 based on the formula, the semi-annual will give you a lower present value. And this is an important concept. What is the concept here? If you're earning more, you need to put less. Why? Because compounded semi-annually will earn you more. Therefore, you need to put less money today. It means you have more return into the future because your money will grow faster and you're putting less money today. This means you need less upfront to reach 30,000 in 5 years. Finding the interest rate or period. What I just said earlier, I said there are 4 factors. There's the present value, the future value, and in between they grow at interest rate and period. 4 factors. As long as you have 3, you can find the 4th. Sometimes you are tasked finding the interest rate or the number of periods. How long, for example, to accumulate 50,000 from 33,330 at 7%? Well, the future value is 50,000. The present value is 33,330, and the interest rate is 7%. The question is asking how long it's going to take. So we don't know how long it's going to take. So the present value is known, the future value is known, the interest rate is known. So how do you solve a problem like this? First, I'm going to show you how to use something called the present value method. Then you could use either the present value or the future value. It doesn't matter. So what do? Using the present value method, you'll take the present value divided by the future value. The present value is 50,000 divided by the future value equal to 33,330. You come up with 0.666. What is that 0.0666? Well, we know the interest rate is 7%. This is not the factor. This is going to help us get the factor. Let me show you how you will use this. So we know it's 7%. So what you will do, you go to the present value table, because we're using the present value. We know 7%, and we want to find the factor that corresponds to the 0.66. If we go down, we're looking for 0.66. We see 0.666 here. We go across and we find out that it's 6 years. So it's going to take 6 years. Why? Because we know we have this factor, 0.666. It's corresponding to 7%. Where is it corresponding at the period? It's 6 period. Therefore, what we need is 6 periods to get to this amount. Now, if you want to, you could prove it. You take 33,333, multiply it at 1.07. This is year 1. Then take this amount and keep multiply it for 6 years. See if you get 50,000 if you want to prove it yourself. So that's one way to compute this. So here what we found is the N. Now also, If we are looking for I, let's assume they told us this. They told us the present value is 30,000, the future value is 50. The future value is 50,000, and they told you you have 6 years, n equal to 6. How do you find I? You do the same thing. What you do is you take if you're using the present value divided by the future value, 0.666. We know n equal to 6. If we know n equal to 6, what you will do, you would say, okay, n equal to 6, I'm going to go across to find, where do I find 0.666? It's right here. I look up, and the interest rate is 7%. It has to be 7%. We already know the answer, but I just wanted to show you. This is one method. The other method is to use the future value method. What's the future value method? It's exactly the same, except we're using the future value table. When we use the future value table, we have the future value in the numerator, the present value in the denominator, and the factor is 1.5. We know the interest rate is 7. We know the factor is 1.5. We go to the future value table. That's why you have to be very careful. Future value table, 7%, and we go across until we find the closest thing to 1.5, 1.501, and it's 6 periods. Therefore, what do we say? We need 6 years, which is the same answer as before. Of course, it will be the same answer. It's just solving the problem using a different formula. It's the same problem. Now, one thing I want you to kind of pay attention to, always the future value table will be greater than 1. The future value of a dollar amount, because you are taking the original amount and adding to it. The present value table of a dollar amount will be less than 1. So notice all these figures, all these factors are less than 1 because you are trying to take a number, multiply it by another number, and make it smaller because you're finding the present value. So notice these are all less than 1. The factors are less than 1. Just kind of something maybe you would remember, and it will be helpful. Let's take a look at this multiple choice question from farhatlectures.com. The time value of money concept implies which of the following? A dollar received today is worth less than a dollar received in the future. Really? No. A dollar received today is not worth less. If you have the dollar today, you can invest this dollar and make more money into the future. A dollar received today is worth the same as a dollar received in the future. Now, if a dollar equal to a dollar, we don't, everything that we talked about in the time value of money will be useless. We don't need the time value. So A is out, B is out. A dollar received today is worth more than a dollar received in the future. Of course, it's worth more. Why? Because this dollar today, I'm going to invest this dollar. It's going to grow at a certain interest rate for a period of time, and I'm going to have more money into the future. C is the best answer so far. The time value of money applies only to savings account. No, it applies to many type of situation, investing, buying a car, making an investment, so on and so forth. Therefore, the answer is C. What should you do? You should go to Farhat Lectures and look at additional MCQs. That's going to help you whether you are studying for your CPA exam, CMA exam, accounting courses, finance courses. Invest in yourself. Farhat is always here to help.